So Jill is asking, are others able to try this methodology?
Yes, I mean, I think the short answer is the methodology is published in a series of papers, and you could take away and run with it. We've also got some software which is publicly available for download. I suppose what I would be upfront about is particularly, the software at the moment is written for our use in order to conduct the analyses, and it's not yet in a terribly user-friendly state. So, I use it to run the analyses because that's what we need to do. But if you want to, I mean, there's nothing stopping you going away and using it, but I would probably suggest working with us. Are the computational models available in statistical software? No, not in statistical software. We've written some specialist Python software in order to do it, and as I say, it's publicly available. It's not massively user-friendly at the moment.
Yeah, and the software was developed specifically for the lung cancer study, and so we didn't have resources to develop a robust piece of software that ordinary users could apply to different data sets. So if you really wanted to use it, you'd be very welcome. But I think it'd probably be simpler if somehow we got together and talked about it, because we could perhaps adapt it to your data set without too much effort on our part. But for you to understand the software probably would involve quite an investment on your part. But the actual method is published in one particular paper. In fact, there's one paper that captures everything, and so that's in the reference section of my slides. So it's one journal paper, and so you could get hold of that, have a look at it, and if you've got any questions, we'd be very, very happy to field them.
I've just seen that Jill's asked another question. I'm with AHRQ supervising systematic reviews. Can this be combined with a systematic review? I suppose if I'm going to be a pedant, then I would suggest that a systematic review is about a systematic search of the literature, pulling all that literature together, and there's then an aggregation technique. So of course, traditionally, one might use a statistical meta-analysis technique to aggregate that data. And the way I would pose our technique is that this is an alternative to meta-analysis. So it's not a substitute for systematic review, because of course if you collect the wrong literature and feed it into the system, you'll get rubbish out of the end. But I would suggest that we should be doing systematic review so that we capture the literature comprehensively. How one then aggregates the literature, I mean, traditionally one of these presented as being another way of presenting that.
I think I'm finally unmuted. I'm not really sure if you can see me, which is kind of embarrassing since it's early here. And okay. But thank you very much. Yeah, I'm just going to do not right now on the webcam thing. I really appreciated your approach. It was it's very novel, and at AHRQ we are involved in asking people to do systematic reviews, and then in helping guideline writers to use the systematic reviews. So this methodology is very interesting, because we do get a lot of feedback from people that the systematic review doesn't actually help answer the question. So I really enjoyed your presentation.
Yeah, and I think it's those questions and those problems that motivate this work. So I'm very keen on systematic reviews, because we do have to take a comprehensive view of the evidence. But the problem from a clinical point of view is, that kind of wave of evidence can feel slightly overwhelming. And really, this approach is supposed to be about trying to both be able to take a systematic approach so that our system will cope with 100 trials, that's fine, but allow you to reason with them and to explore them in a computational and repeatable fashion, so that I can run an analysis and you can run the same analysis, and as long as we share the same data set and we have the same preferences, the same meta rules, we should get the same answer. And it maybe allows us to start exploring which of those choices we make around preferences and meta rules really matter.
Okay, can we answer Karen Head's question about taking health economics into account as part of the implementation?
The answer is yes.
Yes, we wanted to weave health economics into it, and we believe that this can be done. So the initial thought is that we could use the preferences to model economic preferences over possible treatments, but I think there's other things that we could do. So one of the things we're interested in doing is doing a comparison with cost-benefit analyses. So I think there are a number of ways that we could proceed with that. So we haven't actually done anything yet, but it's certainly something we'd really like to do.
We have a hopeful plan to submit a grant that will fund some of that.
I've unmuted you, Karen, unless if you'd like to respond at all.
I don't think there's much to say. Thank you very much. It's very interesting. I am a systematic reviewer working with the Cochrane ENT group mainly, but I've worked for NICE in the past, and so I'm obviously keen to learn new methods, and it's a very interesting technique. Thank you.
Thank you.
Okay, Grace.
So how did you find preferences? Did the patient doctors give their preferences based on their knowledge on the MHRA data? If they did, do you think asking for is still necessary, assuming that they understood the result, we can easily see their preferences? Oh, okay, that's an interesting question. So we defined the preferences, certainly in the lung chemorad example, we defined them upfront and a priori. And I'm not going to suggest that the preferences that we use in the lung chemorad paper are necessarily the correct one to use. I deliberately chose those two preferences because they do seem to capture a clinical intuition, which is, am I only interested in more effective treatment, or am I also worried about both more effective treatment and side effects? Given the patient population, given the outcome of the disease, those aren't unreasonable questions to answer. The second half of your question is actually really interesting, and is something we've started to look at but not yet done comprehensively. So one of the things when you talk about preference elicitation is there's obviously quite a lot of work on preference elicitation, and it's quite complicated to do and to do well. And one of our arguments about building a computational model is, in fact, instead of asking you to define all of your preferences and to spend a long time doing that with you and then maybe spend a long time doing it with the next person, what we might be able to do is to take some fairly standard preferences, and there might be a very wide range of preferences covering multiple domains, health economics, quality of life, number of trips to hospital, all of which are perfectly legitimate things to include in preferences, and explore what answers we get under a multitude of different preferences. Because from a practical point of view, the only preferences that matter are those preferences that drive changes in outcome. And I would then argue that doing that, so what we refer to as stability, so taking a stability-led approach to looking at preferences, is computationally expensive because the computer has to do a lot of work, but that's fine because computers don't get paid by the hour, but actually allows us to save and to simplify a lot of human time. And so I think both of us, but particularly I'm quite interested in exploring that from a practical point of view. Is there anything you want to add? Because we've talked about some of the theory around.
Yeah, so we're wanting to get into the theory of this, and so how do you automatically search the space of possible preferences to see whether a particular decision can be reversed, or a particular preference for one treatment over another can be reversed by looking at these preference relations. And so we think that possibly we can do this automatically. So in other words, how far would you have to go in your preferences in terms of outcomes and their magnitude to actually have a particular superiority for one treatment over another?
Grace, I've unmuted you. You might need to unmute your end if you'd like to respond at all or ask a follow-up question.
No, I think I get the answer, but I think this is a nice network, but in the end, deciding with preferences could be another issue that we should also solve. Thank you for that.
I mean, I agree. Preferences are a big problem in all sorts of areas of decision making. And so within artificial intelligence, there's a lot of research going into how do we model preferences, how do we acquire preferences, how do we analyze preferences. And so there is work we can draw on to help us. But even with all of that, I think there's still more work to be done. So you're absolutely right with your cautious comment there.
Okay, I can't see any more questions, and if anybody would like to raise their hand if they want to chip in. No. I suppose I just wanted to, you mentioned case series. How does that work in terms of your use in sort of trials and meta-analysis? You're using statistical significance as one of the rule criteria. Because that's often an argument in adverse effects, for example, because they will talk about using case series and pulling those together. So perhaps you could tell me how you might think that might work.
Okay. So I think this is something I've been slowly chipping away at, and we haven't done any proper work on it, but there is at a high level, at least in my head. So I'm also the clinical lead for quality assurance at the NCRAS, the National Cancer Registration and Analysis Service. So with one of my other hats on, I have access to huge amounts of individual patient level data, and as a junior doctor I published a variety of case series from working in individual centres. And so it seems that we have randomised trials, and randomised trials are very important to around allowing you to make inferences about the relative effects of treatment between two cohorts, and we're allowed to assume that the difference between the cohorts is because of the treatment, not because of the difference in cohorts, because that's the point of randomisation. But case series might actually tell us other really important things, and so there's a very nice example, in fact, from the glioblastoma world. So in 2005, there were 2 consecutive papers in the New England Journal of Medicine based on a large international multi-center randomized trial about glioblastoma. So they took radiotherapy, and a bit like the lung example, they added some chemotherapy. So, and the people who had chemotherapy did better than the people who had radiotherapy. And that's the results of the randomized trial that tell you that chemo adds better than radiotherapy. And then the next paper, so literally the next paper in the journal, was taking exactly the same cohort of patients, but looking at the presence of a particular marker, which is the methylation of the MGMT promoter. So it silences the gene produces a protein that repairs DNA damage. So if you silence the gene, the radiotherapy and chemotherapy do more DNA damage to the tumour, and therefore the tumour suffers more damage, and therefore people live longer. And that, of course, is a case series reporting the association between a biomarker and survival in a group of patients. And I think that's a very nice example that technically they all came out of 560 patients, came out of a multi-center randomized trial. And what we know about treatment, the effect of treatment A versus treatment B, comes from the randomized data. But actually what we know about the impact of the biomarker comes from taking the same patients and just treating them as a cohort, so just as a group of patients who had some treatment and looking at their outcome. And so the question that then comes up from that is, at the moment we have no sensible way, no formal method of integrating those 2 types of data. So systematic reviews don't really handle it because they're normally restricted to randomized trials. And certainly at the moment, our method doesn't do it because we handle randomized trials. But it would be nice to have a firm theoretical basis to be able to integrate case series and randomized trials. And if you could do that, you could then see that if you had access to a large amount of individual patient data, which we do, you can then summarize some of that into case series. So you begin to get some unification of lots of different sources of evidence. And those different sources of evidence tell you different things about different aspects. They might tell you about side effects, but they might also tell you about the impact of biomarkers on outcomes.
So I think what we can see is that with argumentation, we can, in some situations, we can see how we can make decisions. So what we talked about today is an example of that, that we've proposed a normative model of how to aggregate this information. And that's because we believe that we're taking all of the evidence squarely and weighing it up squarely using the method. A bigger area where in the short term we can apply argumentation techniques, maybe some techniques that I've not talked about today. We can do sense making, which is you've got all of this data, what sense do you make of it? Not necessarily how do you actually make a decision or say this is definitely the best treatment, but just sort of get your head around it. So mapping it out, exactly. And so I think in the short term we can handle case series in argumentation for helping people navigate around all of this data and present it in ways that would allow you to get a better understanding. But there's still a gap between that and actually being able to make decisions. It's possible with some work.
Clinicians tend to be making decisions on that basis anyway, with those gaps.
Yes, and so this is my point, which as a clinician you have to make a decision. And at the moment we have no good, you try and integrate those bits of data, but you have no good formal way of doing it, and therefore the risk is that you end up doing it wrong. And so it would be nice to have something more robust that would allow you to integrate it and maybe flag up when actually, you know, these things don't fit, you know, so don't make these inferences.
There's also something about transparency by showing what you've taken into account, but also I think that in terms of algorithms and making decisions, that presumably this can move on to thinking about what decisions you can make, because that's part of what you're taking into account with the preferences.
You have to make the decisions whether you can make them or not. Do you see what I mean? Yeah. In the real world, you have to make the decisions.
Yeah,
you know,
based on the individual patient at the end of the day.
And you know, but it would be, I think your point about transparency is important. So the point about doing neuro-oncology is, you know, a lot of the diseases I treat have a very poor outcome, and therefore understandably patients and their families go away and they do a lot of reading. And actually one of the most useful things I can do is when they bring me things is go, yes, actually I am aware of that. I have read about it and I know about it, and I don't think we should do X because of this. And it's amazing how much of a difference you could make by being transparent here, because the other option would just be, well, NICE says we do this. And actually all that really does is upsets people and puts their back up. It's much better to spend 10 minutes going, yeah, okay, that's interesting, but actually if you look at it, if you look at that, it turns out that in fact that treatment doesn't work, or I know this paper says that, but it turns out that the biomarker doesn't apply in this group of tumours. So a lot of that is about transparency, about showing patients and their families that you have considered the thing they are worried about and done your best to take it into account, even if that's hard, rather than just ignoring it. That's the best we can do.
Well, I think there's also transparency from the point of view of other people looking at the decision making. And so one of the drivers for doing this work was that we have an aggregation method that we believe is quite transparent and auditable, so people can see exactly which preference rules we've used, which meta rules we've used, what the evidence is. And so it's completely transparent, and so it's just then a matter of turning the handle with the software and out come the results. So anybody else can come along and see exactly why we've got those results out, those recommendations. And so if you want to change anything, you can, but the key thing is it's reproducible and transparent.
And it's quite nice because the input to the system is, you know, a spreadsheet with the summarised clinical trials, and that's very easy to check. You know, you can read a line in the spreadsheet and you can check it against the paper, and that reduces errors. But it also, again, it keeps us very close to the primary evidence.
Yes, you can trace it.
So you can trace it back
Yeah.
and say, but this is what it said in the paper. This is what it's spread in the spreadsheet. You add this preference, this meta rule, and this is the answer you get. And very happy for people to disagree, you know, but it's a very nice stepwise process.
These sort of things, I think now are trying to get data to be available online so that in a sense it's not in a published paper, but actually people could go in and presumably eventually you could change.
Yeah.
You know, you could actually do it even though you weren't the originator or putting the argument together. Somebody could change it like you can with various.
So at the moment we have a non-interactive pre-built version where you can, we've run over, when I talked about in the lung chemo example, looking at both preferences and all the meta rules, we have put all of those pairwise comparisons up on the website. So at the moment that's a non-interactive version, but it allows you to see graphically what happens when you change those options. You can see how the outcome changes. And the idea is to move towards an interaction.
So it would be desirable for guidelines to have this so that you can, instead of just having one recommendation, you have the ability to say what you prefer, what criteria you want to use for meta rules. You come up with your own purpose-made guideline.
Can the data be pooled even in a case where the outcome indicators are different?
Yes. So very much so. So in the running example we had different outcome indicators, and so this is one of the drivers for the approach is to deal with different kinds of outcome indicators.
Amrata, I've unmuted you if you want to come back on that question. You've just read out the question.
Can the data be pooled even in a case the outcome indicators are different? How does one argue the pooling of the data in that case? Because the outcome indicators would be different, and then the units might also be different for each of the indicators. So how does one argue the pooling of these data?
So in my part of the talk I was making this quite explicit in the running example, but also with the study we did with the NICE guideline data, we were dealing with diverse outcome indicators. So in the example there was dealing with the treatment of pill against no pill, and you had outcomes like pregnancy and risk of ovarian cancer, risk of breast cancer, and so on. So you're dealing with very different outcome indicators, and so the preferences over the outcome indicators and their magnitude are the mechanism by which you can pool this data.
Okay.
And I think just from a clinical perspective, although you often have different outcome indicators, within any one trial you will tend to report the same outcome indicators in both arms. So at least for any pairwise comparison of A versus B within a particular trial, you can normally compare the same outcome indicators. And the lung chemo RAD is a very good example. Different people have reported different outcome indicators, and partly that's an evolutionary thing. The first trial in our series was published in 1974, and as you would expect, trials run in 2006 are better than those run in 1974, and they're better at reporting outcomes. And you know, that's what one would expect. But it does mean that the outcome indicators have changed over time. And I think we've got a question from Maggie.
Yes, we've got a question from Maggie, and she would like to ask, what do you do if you have a network but haven't got all outcomes for all comparisons?
So again, we can deal with this kind of problem. So when we looked at the NICE guideline data, possibly I could go back to the slides, but when we were looking at the NICE data for glaucoma, for example, when we were comparing pairs of treatments, we were looking at quite different outcome indicators for each pair of treatments. I think we're getting the slides up here.
Sorry, I'm just going to just keep talking, Tony.
So, yeah, there we go. Yeah, that'll do it. So if you look there, do we have to get rid of that question window?
If I do that. Oh, sorry. There we are.
So if you look there on the first batch, we've got beta blockers versus no treatment, and you can see the outcome indicators. We've got visual field progression, change in IOP. So this is to do with damage to the eye through raised eye pressure. So visual field progression is a measure of damage to the eye's ability. And then we've got two side effects, respiratory problems and cardiac problems. Then we've got prostaglandin analogues versus beta blockers, so a different pair of treatments for the next 6 items of evidence. And we're looking at a completely different set of, except for the first one, change in IOP is common in the two. But the rest, well, some of them are different. Acceptable IOP is not in the first one. We haven't got allergy problems in the first one. Hyperemia, we haven't got in the first one, and so on. And so as you go down, change in IOP is in the first 3 pairwise comparisons, but then is not considered for the next 2. So we're dealing with different outcomes.
Internet's not fast or whatever.
Maggie, I've unmuted you. Did you want to talk?
I don't think I've got a microphone.
We can hear you, Maggie, so you have.
Oh, I have, okay. But I really meant if you've got, in some comparisons, you've only got the efficacy outcome. And in other comparisons, you've got efficacy and adverse events and that sort of thing. So how do you determine which is a better treatment?
It's exactly the same. So if you look here, if I could just have the mouse again, for E17, this is
Carbonic anhydrous.
yes, with beta blockers. So here we've just got one side effect, and yet we're still able to do a comparison and judge whether or not knowing about this allows us to determine whether or not beta blockers are better or inferior to the alternative.
But just to pick up your question, to take then the preferences that we use in the lung chemorad example, if you applied those preferences and you only one could either set preferences or the meta rules, for example, to perhaps only consider the outcomes, to consider a set of common outcomes if that's what you wanted to do. I mean, one of the problems is if the underlying literature is very pathological, then there is a limit to what any technique can achieve. You know, if you've got extremely disparate things, there's a limit to what any technical improvement can add to that.
But then you have to look at the actual mathematics. And so, but then you can actually take 25 patients from this trial and add them to the 32 patients from this trial and add them to, it's statistically, I don't mean it's not adding, but there's like there's methods that you use and come up with results. And a lot of times,
Dario, you need to mute Jill, please.
Absolutely works better than me. Or absolutely, you know.
Dario?
But you can.
I can't mute you.
I also can't mute her.
Seems to have become an organizer as well. So I'm not quite sure how that happened. Anyway, we probably should be wrapping up shortly, so I don't know if there are any other hands raised or any other pressing questions. So obviously I think we've stimulated some conversations going elsewhere. In ARC, that is, so that's a very good, will hopefully, okay, so did you want to make any final comments, either of you?
Only to say thank you very much for joining in. It's been a pleasure. I apologise for the coughing.
And no, just say thank you for joining because it was interesting. I think just to pick up on Jill's point, who said, is it available? Yes, the technique is available, but I think, you know, Tony and I are always interested in working with people and identifying domains where this might be useful. So if you think you have a domain where this might be useful and you're interested, then, you know, drop us a line. We'd be happy to talk about a collaboration.